Hello, welcome to my presentation. My topic name is gradient boosting. Gradient boosting, it is a machine learning technique where we combine the many small weak models to create a one strong models. Also, gradient boosting is helps us to improving the predictions of models step by step. Over this PPT, I will explain what is gradient boosting, how gradient boosting works, and their challenges and limitations, and also the summarize of the topic. Let's begin with the questions. Why do we need the gradient boosting in machine learning? In machine learning, traditional models like linear regressions or single decision tree often miss the complex patterns. But gradient boosting does not miss the complex patterns in machine learning. Gradient boosting is also used to solve problems by improving the prediction step by step in machine learning. For examples, in customer chunks predictions, decision tree is alone may be wrong, but gradient boosting keeps correcting the mistake and making the final model much more accurate. Now let's talk about the what is gradient boosting. Gradient boosting, it is a method that is used in the machine learning to improving the predictions of models step by step. It is a method where we combine the many small as well as weak models, usually the decision tree, into to create a one strong model. Each new trees fix the errors, that is the means between the difference between the predicted value and the actual value. They also used to of the previous ones using the gradient descent. For examples, imagine the housing price of models. The first tree use the only depends upon the size of that house. The second tree is depends upon the adds the locations of that house, and the next tree there adds the house edges. Then the step by step predictions of that models, they get very accurate. Now let's talk about step-by-step working of the gradient boostings. The gradient boostings works is divided into the 5 steps. First is the initialization, second one is the calculate error, third one is the fit weak learner, fourth is the update prediction, and last one is the repeat. In first steps, we start with the simple predictions like the average house price. And in second step, the calculate the error between the predicted value of house and actual value of that house. In third step, we train the small decision tree on these errors. Then we update predictions using the small steps is called as the learning rate. And in last, the process is repeat many times, and we each step the model improve and gets to the closer value of that house. Now see the how gradient boosting works with the help of the example. Imagine we want to predict the price of that house. First, the model start with the simple guess. They saying the cost price of that house is 4 lakhs, but this is not a real cost price for all houses. Suppose one house is actually cost is 3 lakhs. The error between this actual value and that predicted value is 1 lakh. This is a calculate the residentials. Then the small decision tree is trained only on that errors. Because if the house is small, they subtract the 1 lakh between that value, and if the house is large, they add the 50,000 on that value. The model update the predictions a little bit using that the learning rate. So the small house price is becomes to closer the 3 lakhs. This process is repeats in many times. Each new tree keeps fixing the leftover errors of the earlier trees. Finally, after many small corrections, the predictions become is very close to the real house price. Now see the challenges of gradient boostings in machine learning. First challenge is the take more time to train because of it builds many trees one after another. It is slower than a simple model. Then second challenge is can overfit. If we add many trees in that models, the model learns even the noise in that data, which reduce the accuracy on the
one house costing price is the 2 crore when others are around in 40 lakhs. The model spend too much efforts trying to be fixed it. Then last one is the slow predictions for large models. If the models has hundreds and thousands of trees predicting, new data can be slower. For examples, too many trees or outliers, just like a 2000 villas, can spoil normal house price prediction. But very small learning rate makes the model learns too slowly and needs too many trees.
Now let's summarize everything we have learned in that PPT. Gradient boosting combines the many small trees as well as weak models to step by step fix the errors and improving the accuracy. It works well for both regressions and classification problems, but it requires the tunings in to avoid the overfit or slow trainings. Also, modern versions like the XGBoost, Lite, GBM, and also CatBoost are widely used today's generations because they are faster and more efficient to the machine learning in that generation.